Welcome to EDU World Space.
All right, we are drawing a Lewis structure for methyl isocyanate. So here is the methyl group, CH3, and then it says it's attached to NCO. Now we need to get these ones so that they match our total number of electrons. So if you have 3 hydrogens times 1, and then we have 2 carbons times 4 valence electrons, 1 nitrogen times 5, and 1 oxygen times 6. We can figure out quickly how many valence electrons are in our structure. So that is 8, 16, 22 that's supposed to be in there. Right now we have 2, 4, 6, 8, 10, 12. So if we go 14, 16, 18, 20, 22, that gives everybody a formal charge of 0, and that looks like an acceptable Lewis structure there for us. Okay, now it says we're supposed to draw a ball and stick model. So we're going to put those atoms in a circles. Okay, and then so here would be your stick. Now we're supposed to be showing that they're at 109.5 degree angles over here. So that's kind of what I'm trying to do. Since we're doing ball and stick, we can't really show wedges, but here's N. Now N is going to be a trigonal planar. So this one here is 109.5 degrees. This one here is 120 degrees. And so it's going to have a bent shape in that angle there. And then we're going to have a carbon that is going to be linear. So I'm going to have to scroll down here because it's going to be direct line from where that other one was. And then we'll put the O. And the lone pairs would look like this and this. But normally in ball and stick models, you don't really show lone pairs. So that's generally what that shape would look like here. Okay. C says let's predict some bond distances between the molecules, so we can look that up on a table. So a typical C to H bond is going to be about 1.09 angstroms. A typical C to N double bond, which is what we have going on here, is 1.27 angstroms. Okay. And then we have an N to O double bond, and that one's going to be about 1.20 angstroms. Okay. All right, and then finally we have step 4. Step 4 says predict whether the molecule will have a dipole moment and explain. Yes, it does have a dipole moment. I'll put that on here in a different color. So we'll switch to red. So this part over here is nonpolar because it's all C to H bonds. C to H is nonpolar. C to N is a little bit polar, just a little one going that way. Same thing here, N to C. There's just a little one going that way, but C to O is a fairly significant dipole. And so the point of a dipole moment is to say whether or not the molecule is unsymmetrical. And you can see if we kind of put all these arrows together, we kind of have an overall dipole that's pointing in this general direction away from that nonpolar region towards that other region. Okay, hope that answers your question.